Hi, I'm Max, and I want to give a talk about teaching finite elements interactively. I'm a PhD student at the chair of continuum mechanics at Ruhr-University Bochum, and in Germany, courses consist most of the time of lectures and exercises. I had the duty to prepare the exercise materials for the course Basics of Finite Element, which is a course for civil engineers and mechanical engineers. As a master student, I enjoyed two machine learning courses, which were taught exclusively by Jupyter Notebooks and inverted classroom principle, and I thought it would be very nice to transfer this approach and the principles behind to finite elements. However, there is a problem, because the course is for civil and mechanical engineers, so they have no or only a little background in programming. So I need a centralized environment for the students that I can fully control. So whenever something technical goes wrong, I can kick in and fix it. And the environment needs to be accessible at any time, and especially by a browser, because a browser implies a low technical barrier. And if the environment is accessible at any time, students can just follow their own path and their own track. So they can prepare after the exercise some parts that they missed or which were too fast for them. What we came up with is a Jupyter Hub server with Pluto proxies. And you have a service that does the user management for you. And in this particular case, it's Jupyter Hub. However, there are also other approaches, but we will focus in this talk on the Jupyter Hub approach. And another important aspect for me was that the students have access to the same installed packages that I install on the server globally. So what you need to do for this is you need a shared directory for all users, and you need to point the Julia depot path variable to this directory. I have a detailed blog post with the instructions for it linked here, and also a link to the Jupyter Lab extension that is needed. So let's get right into it. So I have here the Jupyter Hub interface. So this is how it looks like if you type in the IP. And now I log in with my user account. And this is the usual interface of Jupyter Lab that you may or may not know. However, with the small twist that you have here, the Pluto JL button, which is essentially the Jupyter Lab extension I just mentioned in the slide before. And if you click on it, you will see that you have here a user-specific path. So the user do not share the Pluto server. Each user has its own Pluto server, and you have this endpoint Pluto here, which exposes you to the regular Pluto interface. And this is basically my technical setup. We will later talk a bit more about some specific details, but now let's get right into the exercise materials. I learned a couple of things while doing this course, and I just want to give you some hints that may benefit you if you want to do something similar. So the very first thing that I showed the students is how to write Markdown cells, because they need to be able to make their own notes, such that whenever there is a exercise, they can just ask questions that came up while preparing the exercise materials. Another important aspect is these checking boxes here, which I basically copied from the computational thinking course. And whenever you have a task, you need to have a fine-grained checking going on. Because when there is a fine-grained checking, people are more likely to get involved with the task than when it's just at the end some result that is checked. And this is really important. Student gave a lot of feedback about this, and they really liked if it's a really fine-grained checking structure. Another important box hint was that you have these blue boxes with this blur effect. They are also copied from the computational thinking course. And if you hover over them, the blur effect is gone. And you can utilize this for small hints to the task. And I try to provide at least one of those small hint boxes for each task. But in best case, there should be two, whereas the first is a small hint, whereas the latter is um, already something which is close to the solution. And this is how I approached exercises in general. And of course, I always try to be as interactive as possible. And even though it doesn't make any like meaningful understanding in the task, people just get involved by it by some interactivity. Because if you see something like this and you can use sliders or what else, um, people are just more likely to get involved with it. Another important aspect is that I always used for each exercise this Pluto environment, even though there were no computation involved. There were two exercises where we only did symbolic things. And in this case, I prepared a Pluto notebook like this, where we have a lot of writings and especially LaTeX stuff. Um, but the good thing is that they can always export it to PDF. And another important aspect is that they are always seeing this very same environment such that they can get used to it. Because if you change things, people are just not likely to get used to it. Another important aspect for me was the integration with SVGs. So whenever you have a SVG, you can just open it as an HTML file and then have a nice figure inside your Pluto notebook. Of course, now you can use, for instance, symbolics.jl to also test in a nice way symbolics. Back then, I just used strings, which is not optimal, but it was okay for the purpose of this course. Now, let's get into the middle of the semester where we coded already the first own finite element code for truss elements, because truss elements simplify things drastically, and it's a good beginner task. There are a couple of things I want to show you, and this is whenever you have a function, I recommend to provide a good description as a docstring above, because then you can just point the students whenever they are at a different part of the notebook to the documentation of it here. And this was quite essential for me because the students can just look it up on their own, and by this also get used with the documentation feature of Pluto. Now let me show you the nice activity of Pluto in one example. So here I use Luxor to draw interactively the structure which is prescribed by the student. So you have some code that is able to compute a structural problem of a truss structure, and you have this problem setting right here. However, if you make such statements here, it's very likely to have a numerical error in there, or you may or may not have a typo. And so it would be nice to have a graphical verification. And I chose for this Luxor. So whenever you change a coordinate, you will see that the drawing below will also change. Okay, but trusses are not everything, and we wanted to have full-fledged finite element computations. And in finite element computations, the results is even more abstract because you just have a one huge vector, and this vector is not nice to verify. And so you need some graphical output such that you can verify your finite element computation. And for this, I used Marquee, in particular WGL Marquee here, and which spawns under the hood a JS server. And now the problem is that this server needs to communicate with the Pluto server here. And Simon Danisch was so nice and helped me out a lot on this. And so, for instance, this typical finite element example in structural problems which is called Cook's membrane. You have a structure like this, which is fixed on this side, and you apply a traction load on this side. And you want to visualize this because there are a lot of nice features that you can see from this computation. And with Maki, you can have this all on the server side while the graphics are rendered in the browser here. And with everything you need to have, so we can zoom in, crop it, and so on. And by this, you can just check if your computations are right or not. And if not, you can fix it. And of course, you can have interactive plots by plots.jl as usual. And with this, I would like to end my talk with a small outlook and an acknowledgement. So for me, I need to find a better way to check tasks with index notation, especially with tensors, but also to integrate symbolics.jl for a better way to check symbolic tasks. I want to translate the material to English, and if anyone is up to, it would be very nice to have different tracks for mathematics, physics, computer science, and engineering students, and then afterwards publish it such that everyone can access it. And I would like to acknowledge Dennis Ugemann for his technical support to set up the server, so the server which hosts the Jupyter Hub server, and Simon Danisch for his help with Maki and JSServe. Thank you very much for your attention, and I hope I inspired some of you to may or may not copy this environment. Thank you.
Okay.
Okay, that's great. Thank you, Max.
Thank you. Very interesting.
Yeah, we have some questions from actually the organizers. You were making this for students, of course. Now, you mentioned that these students are not necessarily too familiar with programming. So what sort of issues come up with them?
A lot. So usually we plan to have like 1 or 2 exercises where we introduce the programming language or something. And now we decided more or less to use Julia. So I have like 1 or 2 notebooks to just present the most basic Julia features, and then we go on and make more difficult things. But most of the time when something went wrong, it was because the how I control their answers was not fine-grained enough. So they essentially have some error and they're not able to debug it because they are not used to read error messages. So let's say some function is waiting for some kind of data structure, but they're passing something else, and then you get some error message, and it's actually quite easy to debug. But if you do not have experience, then it's very hard to encode this.
Okay, Max, another question I have. How long did it take for you to set up the whole Julia, the whole Jupyter Hub server? Because I've known it's kind of notorious for being too hard. And what is your specs? Like, do you have a whole cluster, or is it just a big machine?
It's actually just one machine, which is which is located at our chair, and it's behind the. It's inside the network of the university. I'm not an expert in web technology whatsoever, but essentially you have to connect to the VPN of the university, and then you can access it. So you have some protection, so to say. And the specs of the server are, I think it's 32 cores or something, and 1 GPU. However, we do not use the GPU at all. So it's plain the CPUs that are used inside the course, but it's totally fine for, let's say, 20 students or something.
Oh, that's nice. Okay, that's interesting.
Yeah, question from Fons actually. What future features from Pluto would be useful for you as a teacher or useful for your students based on the feedback you received?
Yep. So currently the most upcoming thing is that I need to fix, probably with Simon, the current WebGL Maki release. So in the current release, I think it does not work. But I need to upgrade now the server, and so it probably will be fixed soon. And other than that, I think as a teacher, it's very nice to think about to utilize the new web API that was presented yesterday, because then I can just request implementations while doing the exercise and do not necessarily have to log into the user accounts, which is very nice, because then I can just put on a terminal and then request what's going on.
Okay, good.
That's a great idea.
Great.
Amazing.
Yeah, it's very nice to hear about features are immediately starting to be useful. All right, so for the next talk, we're going to have interactive mathematical storytelling.